one. For this problem, which is another one that I've been getting questions about, we are given two balls. We know that they have the same charge Q. We know that their masses are given. We know that their radius between them is given. And we know that theta is given. So now notice that we actually have a free body diagram. Because of the symmetry of the problem, we can solve for just one side of the problem. If it weren't symmetrical in mass and charge, then the geometry would not also be symmetrical. So let's start with a point. We have Ft, downward, we have mg. Over, we have the electric force, or the Coulomb force. And by the Pythagorean theorem, we can say that Ft squared is equal to mg squared plus Fe squared. Let's start by finding Ft, however. We know, because of the nature of vector sums, that Fc and mg being at right angles tells us that the Pythagorean theorem holds, but it also tells us that we can use sine and cosine to find these as components. It's an algebra problem from Physics 1. So solving, we have mg must be equal to Ft times the, and this is the downward component, cosine of theta. Well, we have m and g, and we have theta, so now we're given Ft. So Ft is then equal to mg over cosine theta, and we know that. Now again, using the same Physics 1 thought process, we can solve for Fc, and it's helpful to think about what form Fc takes. The Coulomb force takes the form K Q1 Q2 over R squared. However, in our case, we know that Q1 and Q2 are equal, both by symmetry and by the given arguments. So let's write that here just to be clear. So we can rewrite this as K Q squared over R squared. And taking one more small step, we have K over R squared times Q squared. Pulling that back over here, we know that Ft sine theta is equal to Fc is equal to this form, K over R squared times Q squared. And we are given Ft, so let's plug that in. This implies that mg over cosine theta times sine theta is equal to K over R squared times Q squared. Now I'm going to move this equation up, and then we will finish this solution. So now we can combine these into a tangent theta, and we are given mg because we're given m, and g is a constant. So we have that mg, which is a known, times tan of theta, which is a known, over K over R squared is equal to Q squared. And manipulating this one more time, we get mg tan theta r squared over k is equal to q squared. So then q is equal to the square root of mg tan theta r squared over k. Thank you.